Assalamu alaikum, my name is Fahim Afzal and today we are going to design node filter and its Bode plot on Matlab. So what is node filter? Node filter is usually a simple LC circuit which is used to remove a specific interfering frequency. For example, this technique also used in radio receivers that are so close to a transmitter that it swamps all other unuseful signals. So now coming to our calculation, things that we need to assume in our calculation are frequency range and inductor. So our frequency range will be 6 kilohertz to 10 kilohertz and inductor's value will be 1.2 Henry. FL or means are low frequency 6 kilohertz, FH mean higher frequency 10 kilohertz. We can also call them FL omega 1 and FH omega 2. Resonance frequency FR, this is its formula, FL plus FH divided by 2. Here we get FR is equal to 8 kilohertz. Bandwidth is higher frequency minus lower frequency, or omega naught omega 2 minus omega 1, or FH minus FL, we get 4 kilohertz. So a filter that prevents a band of frequency between two designated values. Here I explain that FL or omega 1 we can call FL or omega 1, or FH or omega 2, and we can call our resonance frequency FR equal to omega naught. So from passing is variably known as band stop, band reject, or notch filter. These three are same in passive filters. Now general graph of our notch filter. This is the general graph of our notch filter. Here you can see that this is our FL 6 kilohertz and FH 10 kilohertz, omega 1, omega 2, and this FR is omega naught. This is an ideal and actual frequency response of a band stop filter. So we assume inductor's value 1.2 Henry. So we are going to use passive notch filter with RLC circuit. So resonance formula is 1 over 2 pi under root LC. So by putting here we know resonance frequency and inductor's value. The unknown thing is capacitor, so we take it out on other side of equal and we calculate the capacitor's value 2.63 microfarad. Now we need to calculate the quality factor to calculate resistance. For resistance we need to find quality factor. Quality factors formula is FR over bandwidth. We know resonance frequency 8 kilohertz, bandwidth 4 kilohertz, so we get our quality is equal to 2. Now for resistance we have formula R is equal to 2 pi FR L over Q. Here we have known all the values except resistance, so we will find resistance. This is the graph circuit diagram for notch filters. Now we are going to implement it in multisim or Proteous on different frequencies to get V naught peak to peak, and then we can find gain AV, and then we will get graph. After performing it on Proteous on all these frequencies, we get this V naught peak to peak, and our input it will remain same throughout these frequencies, 8 volt here. So the gains formula is V naught by Vi. So after getting V naught we divide it by 8 and get this gain. This is the graph. I draw it using all these values, frequency here and gain here. On these frequencies I get all this gain, and finally this graph. For Bode plot of notch filter we need to find transfer function of the calculated value to draw the Bode plot on the Matlab. So this is the formula given in the book, ENA electrical fundamental book, and in 14th chapter. So after I take j omega is equal to s, and after solving this I get this form, and after I know all these values I have calculated earlier, and then I put all these values in it. I have mentioned them on this side. You can see here R is equal to 30.159, L is equal to 1.2, capacitor is equal to 2.83 microfarad. So now MATLAB code seems S, and this will be our numerator. Num is equal to all these values, and denominator den, and all the denominator values, and then we find the transfer function tf num comma den, and this transfer function is going to save in h, and then we use this Bode plot command, and we also use grid to so that we can see the graph clearly. So this is the circuit that I implement on Proteous to find these values, and then I finally draw this graph, and this is the code, and this is the Bode plot result that I got after writing this code into the MATLAB. So thank you very much. Allah Hafiz.